In this example, suppose that the production function P of xy equals 2000 times 0.5 times y to the 0.5 is known, where x is the measure of units of labor and y is a measure of units of capital invested. Determine the marginal productivity of labor and the marginal productivity of capital when 16 units of labor and 144 units of capital used. The function given as p of xy equals 2000 times x to the 0.5, y to the 0.5. To understand the problem, since x measures the unit of labor and y measures unit of capital, the end goal is to find the marginal productivity of labor. Focus on the labor. Labor is the x. So this piece is the partial derivative of the p with respect to x, where the marginal productivity of capital, where capital represented by y, is the partial derivative of the p with respect to y. When 16 units of labor, that means when x equals 16 and y is 144. Same over here. So we are going to find the partial derivative of the p with respect to x and the partial derivative of the y of p with respect to y. Let's get started. The partial derivative of the p with respect to x, we're gonna treat y as the constant. We target on the x. This is just the power function in general. So 2000 as the constant multiple, the same as y to the 0.5 is treated as a constant. So the derivative of x to the power 0.5 using the power rule is 0.5 times x to the negative 0.5. And then simplify it to be 1000 times y to the 0.5, x to the power negative, we bring it down to the denominator to make it convenient in the form that we can calculate. And also 0.5 is 1/2. We can write it as the square root. So square root y on the top divided by square root x on the bottom. We evaluate when x is 16 and y is 144. So the partial derivative of the p with respect to x, when x is 16, y is 144 equals 1000 times the square root of 144 divided by square root of 16, or 1000 times 12 divided by 4. 4 and 12 reduced to be 3, and so going to be 3000 as the value, as a marginal productivity of labor when 16 units of labor and 144 units of capital used. The next part, the partial derivative of the p with respect to y, or the marginal productivity of capital. We find the partial derivative with respect to y of the function 2000 x to the 0.5, y to the 0.5. When you find the partial derivative with respect to y, we're going to treat y as the variable, so then the rest is going to be treated as a constant. In this case, 2000 as a constant multiple, x to the 0.5 as a constant multiple. So we find the derivative of the y to the power 0.5 using the power rule. It is 0.5 times y to the power negative 0.5. And then simplify to be 1000 times x to the 0.5. And then the y with the negative power, will bring it down to make it positive power. Or we write in the nice looking form as 1000 times square root x divided by square root y. And then we're gonna evaluate the marginal productivity of capital, or the partial p with respect to y, when x equals 16 and y equals 144. it becomes 1000 times square root of 16 divided by square root of 144. We have 1000 multiplied by 4 on the top divided by 12 on the bottom. And then simplify to be 1000 divided by 3, or 333.33, repeating.